Hello students, so today I shall be discussing about the topic known as polymorphism, function overloading and constructor overloading. Now let's start with the topic known as polymorphism. First of all, what do you mean by polymorphism? The word polymorphism means having many forms. Let's take a real life example of polymorphism. Let's talk about a person. A person at the same time can have different characteristics. He can be a man and at the same time he can be a father, a husband and an employee. So the same person can show different behavior under different circumstances. And that is one example of a polymorphism as a real life example. In C++, polymorphism is mainly divided into two types: compile time polymorphism and runtime polymorphism. Now, compile time polymorphism is that polymorphism which happens during the compilation time. So just before the program executes and runs, it is the duty of the compiler to parse and check every statement of the program whether it is syntactically correct or not. Every statement inside that program shall be checked whether it conforms to the rules of the C++ programming language or not. And at the same time, if the program has objects or functions that shows polymorphism, they can be traced during the compile time. And such type of polymorphism is known as the compile time polymorphism. The two examples of compile time polymorphism are function overloading and operator overloading. And the one that is included in this chapter is the function overloading. I shall be discussing about function overloading in detail in this particular chapter. The other type of polymorphism is the runtime polymorphism. This type of polymorphism occurs when the program has already been compiled, and just as the program starts to execute and run, this type of polymorphism can be traced in the program. The example of a runtime polymorphism can be the virtual functions. Now in this chapter, you will be learning about the type of compile time polymorphism known as function overloading. So let's start with function overloading now. Now I want all of you to refer section 5.6 in your book, okay, and look at the topic known as overloaded class member functions. This means you can overload the member functions inside a class, okay, but before that you need to know what is function overloading. When there are multiple functions with the same name but different parameters, then those functions are said to be overloaded. Now look at these three member functions inside the class known as employee. Okay, the name of each of these member functions is emp over. Okay, if you look clearly here, it's emp over, which is the name of each of these member functions. So what we can conclude from here is that these three member functions have the same name, which is emp over, but they have different numbers of parameters. If you look at the first member function emp over, it has got 4 parameters. which are eCode, eName, eDesic, and eSalary. In the same way, the second member function bearing the same name EMP over has got three parameters, which are eCode, eName, and eDesic. And then the third member function, which also bears the same name EMP over, has got only two parameters, which are eCode and eName. As a result, all these three member functions, they bear the same name known as EMP over. Okay, the only thing they differ is that they have different numbers of parameters. Okay, the first one has 4 parameters, the second one has 3 parameters, and the third one has 2 parameters. As a result, we can now say that these three member functions show the property of polymorphism because they bear the same name but exist in different forms. And the polymorphism that is represented by each of these three member functions is function overloading, because they have the same function name, which is EMP over, but different numbers of parameters. Now note that I am using the word function overloading because each of these three member functions whose name is EMP over do not resemble with the name of the class, which is employee. So these are the member functions only, not the constructors. Function overloading has been achieved through these three member functions because they bear the same name but differ in the number of parameters. So that is what has been said here. When there are multiple functions with the same name but different parameters, then those functions are said to be overloaded. Now look at this point. It says functions can be overloaded by change in number of arguments or change in type of arguments. If we look over here, these three member functions, they are overloaded because they possess different numbers of arguments or parameters, and also they possess different types of arguments or different types of parameters. If you look over here, this member function EMP over possesses two parameters or two arguments, which are eCode and eName. Okay, the data type of the parameter eCode is int, whereas the data type of the parameter eName is char. Okay, with the size as 25. Then if you look at this member function EMP over, it has got one extra parameter eDesic whose type is char and size 15. Then over here, this member function has got 4 parameters, which are eCode, eName, eDesic, and eSalary. Okay, one extra parameter eSalary has been added, okay, whose data type is float. If you look at this parameter eSalary, this is not present in the next two member functions below. So that's what has been said here. Functions can be overloaded by change in the number of arguments or change in the type of arguments. Now refer the section 5.6 of your book and see the example program, which says write a program to demonstrate the concepts of overloading class member functions. So with the help of this program, okay, you can also find this program inside your book in section 5.6. Okay, now with the help of this program, I am going to demonstrate the concept of function overloading. The program has a class identified by the name employee. These are the data members declared as private, so they shall not be accessible outside of the class. This is a parameterized constructor declared as public. Since, as I have already explained you, that constructors should always be declared inside the public section. That's why this particular parameterized constructor has been declared as public. In addition to the constructor, there are three overloaded member functions, okay, which are also declared as public. Then there is a member function known as display, which is also declared as public. The program shall start from the main, because the main is the inception of a program. Okay, inside the main function there is a body region. Okay, this is the first statement inside the body region. This statement declares an object bearing the name XEMP. The object named XEMP has been created out of this class known as employee, and this object has been created with initial values such as 100, Sujata, computer, and 12500. Now we know that as soon as an object is created from a class, the constructor for that class is invoked. So for this object XEMP, with these initial values, this parameterized constructor shall be invoked, where the initial value 100 shall be for eCode, Miss Sujata shall be for ename, PGT computer shall be for edesig, and 12500 shall be for eSalary. Now the body region of this constructor has been defined outside of the class. Okay, so the control is now going to move from this portion of the program to here. The constructor now shows its body region, which includes these four statements. Now we know that the purpose of a constructor is to initialize the data members of a class. Okay, now these are the four data members of the class, okay, which are EMP code, EMP name, EMP desig, and EMP salary. So over here the constructor is initializing the first data member EMP code with the value from the parameter eCode, which is nothing but 100. Then in the second statement, the constructor is initializing the data member EMP name with the value from the parameter ename, which is nothing but Miss Sujata. Then in the third statement, the constructor is initializing the data member EMP desig with the value from the parameter edesig, okay, which is nothing but PGT computer. And in the last statement, the constructor is initializing the data member EMP salary with the value from the fourth parameter eSalary, okay, which is nothing but 12500. So now EMP code shall hold 100, EMP name shall hold Miss Sujata, EMP desig shall hold PGT computer, and EMP salary shall hold 12500. Now once this step is done, that is, the object XEMP has been created and the respective constructor has been called, with the data members being initialized with these initial values, the control now moves into the next line. Okay, now with the help of this object known as XEMP, it is trying to access the member function display. The access has been granted because the function display has been declared as public. Now the function body of this member function display has been defined outside of this class, so the control is again going to jump from this part of the program to here, where it is now executing the function body of the member function display. Okay, the first statement prints the text employee code and then the value of the data member EMP code, we know that the value of the data member EMP code was 100, so it's going to print employee code 100 into the output. So here it is. The second statement prints the text employee name and then the value of the data member EMP name. Now the value of the data member EMP name was MS Sujata. Okay, so it's going to print employee name MS Sujata into the output. So here it is. Okay, just after the first one. And then the fourth statement prints the text employee salary with the value of the data member EMP salary. Okay, sorry, I forgot to mention about the third one. Okay, the third statement is going to print the text employee designation with the value of the data member EMP desig. We know that the value of the data member EMP desig was PGT computer. Okay, so it's going to print employee designation PGT computer into the output. So here it is, just after the previous two. Then the fourth statement prints the text employee salary along with the value of the data member EMP salary. Now we know the value of the data member EMP salary, which is 12,500. Okay, so it's going to show employee salary 12,500 in the output. So here it is, just after the previous three. Now once the function has been executed, the control is going to move into the next line. Okay, and in this line, using the cout command, it's executing the endl operator. Now endl means end of the line. Okay, so it's going to skip one line. As a result, just after printing these four in the output, it's going to skip one line. That is, the control is going to move into the next line over here. Now what it's going to do over here, let's see. The next statement includes a for loop, okay, which is going to print the equality operator 45 times, okay, because the value of the variable I ranges from 1 till 45. So that prints this equality operator 45 times in the output. Then the next statement displays this text, okay, employee with overloading class method into the output. So that is displayed over here. The next statement also includes another for loop, okay, where it is going to print the equality operator 45 times. And you can see this equality operator getting printed 45 times over here. Now using the same object xemp, it is trying to access the member function emp over. Okay, now will the access be granted? Surely the access shall be granted, because each of these three member functions, they are overloaded because they have the same name emp over. Okay, and only way that they differ is the number of parameters. Okay, and since they are declared under the public access specifier section, okay, so the access to these overloaded member functions is granted. Now in this statement, the object xemp shall invoke and access the member function emp over by passing these four initial values into the parameters. So these four initial values shall be assigned to four different parameters in the member function emp over. So now which of these three overloaded member function will best fit to hold these four initial values as parameters? So out of these three, it shall be the first one, okay, because the first member function holds four set of parameters, okay, which are ecode, ename, edesic, and esalary. The other two overloaded member functions contains only three set of parameters and two set of parameters, which in no way can hold all these four initial values. At least one of these values will be opted out. This one will opt out one initial value, that was 12,500 for esalary, and this one is going to opt out two initial values. Okay, one is the PGT computer for e-DESIG and the other is 12500 for e-salary. So only this is the overloaded member function, okay, which best fits and best matches to store all those initial values into its parameters. The initial value 100 shall be for e-code, the initial value Sujata shall be for e-name, the initial value PGT computer shall be for e-DESIG, and the initial value 12500 shall be for e-salary. Now as the function body for this function has been defined outside of this class, so the control is again going to jump from this portion of the program to here. The first statement assigns the value of the parameter e-code into the data member EMP code. Now we know that the value of the parameter e-code was 100, so 100 shall be assigned into the data member EMP code. Then the second statement assigns the value of the parameter ename into the data member EMP name. Now as ename holds the value Miss Sujata, so Miss Sujata shall be assigned into the data member EMP name. In the same way, the third and the fourth statements assigns the value of the parameters e-DESIG and e-salary into EMP DESIG and EMP salary. Okay, the value of the parameter e-DESIG was PGT computer, so that shall be assigned into the data member EMP DESIG, and the value of the parameter e-salary was 12500, so that shall be assigned into the data member EMP salary. Now once this statement gets executed, okay, after the object xEMP invokes the member function EMP over with these four initial values, then in the next step, using the same object xEMP, it is invoking the member function display. The member function display shall be invoked, okay, and inside its body region it's executing each of these four C++ statements, okay, where it prints the text employee code, employee name, employee designation, and employee salary, along with the values of the data members EMP code, EMP name, EMP DESIG, and EMP salary. And that can be seen here in this output. Now using the same object xEMP, this time it is again invoking the overloaded member function EMP over, okay, now with only three initial values, okay, which are 101, Miss Raman, and PGT match. So for three initial values out of these three overloaded member functions, only this one shall be invoked, because for three initial values it has three parameters, okay, where the initial value 101 shall be for e-code, Miss Raman shall be for e-name, and PGT match shall be for e-DESIG. The function body has been declared outside of this class, so the control is going to jump from this portion of the program over here. Inside its body region, the data member EMP code has been assigned the value of the parameter e-code, which is 101. Then the data member EMP name has been assigned the value of the parameter e-name, which was Miss Raman, and the data member EMP DESIG has been assigned the value of the parameter e-DESIG, which was PGT match. Once this statement gets executed, the control moves into the next line, and now using the same object xEMP, it is again invoking the member function display, which brings the control over here. Inside its body region, the first statement prints employee code, okay, and then the value of the data member EMP code, okay. The latest value of the data member EMP code was 101, so employee code 101 gets displayed in the output, and that is shown here. The second statement prints the text employee name and then the latest value of the data member EMP name, which is Miss Raman, okay, so employee name Miss Raman. Now here we have employee name Mr. Raman. Then the third statement prints the text employee designation along with the value of the data member EMP DESIG. The latest value was PGT match, So employee designation and PGT match. So here it is, it can be seen in the output. Now the fourth statement prints the text employee salary and then the value of the data member EMP salary. So now what might be the value of the data member EMP salary? Now if you look here, when I invoke the member function EMP over, okay, with only these three initial values, 101 represents E-code, Miss Raman represents E-name, PGT match represents E-desig. Okay, there was no initial value for E-salary. Okay, so it's going to take the previous one, okay, which was 12,500. So now the text employee salary along with the previous value of the data member EMP salary 12,500 shall be displayed in the output. So that is seen here, employee salary. Okay, here 12,500 is the previous value of the data member EMP salary. Now once these two statements got executed, the control shifts into the next line, okay, and it then tries to execute this particular statement. Okay, again here the object xEMP is trying to invoke the overloaded member function EMP over, okay, with only these two initial values. Okay, here 102 shall be for E-code and Miss Rekha shall be for E-name. Okay, so from here the control is again going to move from this calling function into this call function. If you look at this call function, okay, the overloaded member function EMP over contains only two parameters. Okay, here E-code will take the first initial value, which is 102, and E-name shall take the second initial value, which is Miss Rekha. Now inside its body region, the first statement assigns the value of the parameter E-code into the data member EMP code. Now since the value of the parameter E-code was 102, so 102 shall be assigned into the data member EMP code. Okay, again in the second line, using the string copy function, the value of the parameter E-name shall be assigned into the data member EMP name. Now we know that the value of the parameter E-name, okay, which has been recently assigned the value Miss Rekha. So now Miss Rekha from the parameter E-name shall be assigned into the data member EMP name. Okay, so to sum it up, EMP code shall hold the value 101 and EMP name shall hold the value Miss Rekha. Sorry, the data member EMP code shall hold the value 102, not 101. Now once this statement gets executed, in the next statement, using the same object xEMP, it is invoking the member function display. So the control is going to jump from this calling function into this call function. Okay, now inside its body region, the first statement prints the text employee code along with the value of the data member EMP code. Okay, the latest value assigned was 102, so employee code 102. And then in the next statement, it prints the text employee name and then the value, okay, the latest value assigned to the data member EMP name, okay, which was Miss Rekha. So employee code 102 and employee name Miss Rekha shall get displayed in the output, and that can be seen clearly here, employee code 102 and employee name Miss Rekha. Now the question is, what will these two statements display in the output? Okay, the third one shows the text employee designation, okay, along with the value of the data member EMP desig. Now since using the object xEMP, I have called the overloaded member function EMP over, okay, with only these two initial values, where 102 shall be for E-code and Miss Rekha shall be for E-name. So I haven't touched the other two parameters, which are E-desig and E-salary. Okay, so E-desig is going to take the previous value, which is PGT match, and E-salary is also going to take the previous value, which is 12,500. So employee designation, PGT match, and employee salary 12,500 shall be displayed in the output, and that is true here. It's clearly shown in the output: employee designation, PGT match, and employee salary 12,500. So this is what we get to see in the output once we execute this program using the object xemp. Okay, first time it is invoking the overloaded member function emp over, having 4 different initial values for 4 different parameters. Second time, using the same object xemp, it is invoking the overloaded member function emp over with 3 different initial values for 3 different parameters. And again, third time, using the same object xemp, it is invoking the overloaded member function emp over, okay, with only 2 initial values for 2 different parameters. So the first time the object was invoking this overloaded member function, okay, having these 4 parameters. Second time the object was invoking this overloaded member function having these 3 parameters, and in the third time the object was invoking this overloaded member function with only these 2 parameters. So depending upon the number of initial values passed, the corresponding overloaded member function has been called. So that's all about the concept of function overloading, and with this I end my presentation here. In the next presentation I shall be explaining you about constructor overloading, and that shall be the part 2 of this video. So I want you to immediately watch that video soon after this video. Now I shall end this part 1 here.